So for our first video here, we're going to be taking a look at a pretty tricky example because they're using kind of a shady word that makes you think about doing something else that you normally would do in this situation, but it's really the wrong way to do this question. And it's just kind of the nature of the beast when we're looking at with some of these questions that you got to be a little bit smarter than the question that they're actually asking. Let's take a read of it and let's see if we can kind of find this sort of shady word that they're using. Judith is a 52-year-old accountant who has invested money into 4 different options, each with a different risk factor and a rate of return. Determine the average rate of return in her investment portfolio. You might read that and say that it's pretty standard, but there's actually a really, really bad word that's in it right now, and that is this word, average. Whenever you get average, your instant thought is to take the average of something that you've been doing since, I don't even know when averages are kind of introduced to you, probably like, I don't know, grade 5 or something. I don't know, maybe sooner. And that's to add up all the terms and then divide by that number of terms. Here's the problem. We're dealing with percentages here, and you can't take the average of percentages of something. Percentages are inherently multiplicative, meaning that to get the percentage of something, we need to we need to multiply it onto something. Averages are additive, meaning you add things up and take the average of them by dividing by the number. So this is kind of our issue. A lot of the times when people would do this question, they would take, hey, determine the average rate of return on an investment. They'd essentially say, okay, well, I just won't do this. I won't do this, and I'll just take the average of all these percentages and then divide them by 1, 2, 3, 4. That's actually the incorrect way to do this question because of the property of what it even means to be percentages. It's multiplicative. You have to multiply them. I can kind of go into a little bit of this detail afterwards, but for right now, all we have to know is that that would be the totally wrong thing to do. The right thing to do here is to calculate the return on each of her types of investments that she has, and then add up all of her return afterwards. So what we're going to do here is we're going to get what is her return if her amount was $8,155 and her rate of return was 0.3%. So let's go ahead and let's figure out what her rate of return is. We're basically just multiplying these things as decimals, and I'll write down the decimals for us, because that also can be something that we get a little bit hung up on. As a decimal, 0.3% is 0.003. 1.1 is going to be 0.011. 2.9, 0.029. Right, I'm just dividing these numbers by 100. And then 6.8, 0.068. So I'm just going to go ahead and I'm going to figure out what the return is for all these numbers. You already know what we're going to do for this. If this is the amount and this much return is going to get, then you're just going to multiply these two together and then add the original amount. You could, if you wanted to, you could just put like a 1 here instead. And you could change this first number to 1 if you wanted to. And then that will get her total amount for that. But just figure out what you want to do. You can either multiply by 0.003 and then add whatever you get to the original amount to get what her return amount is. Or you can just multiply it by 1.003 because 1 would obviously indicate the original amount. I'm just going to pause the video here. I'll fill in what we need for that, and then we'll talk about the next step. Okay, so kind of continuing on with this, I've filled in all of my return column here. I guess I should kind of say this is going to be like her total amount afterwards. Total amount afterwards. I'll show you how to do this problem a different way in a sec, but I kind of like just dealing with this way because it kind of follows the formula rather than kind of does half of it in the same go. We'll see what that makes sense in a second. So I calculated all the total amounts afterwards here. I'm just going to add up all the things that I have here now. So if you have them in your calculator, it's pretty easy just to kind of work your way up and adding them all out. Yep. And then my 8,000. Okay, so I have her absolute total amount after all of her rate of returns is, what is that? $245,534, and I'm going to round it to 2 decimal places, so that should be 89 cents. We're going to add up her total here as well. So we're just going to take all of her amounts. This would be like her principal amounts. And we're just going to add up all those as well. I'm just using a calculator for this. I'm not actually doing this in my head. 149,360. 233,365. Okay, so we have this. Now, I want to kind of just show you if you did this question the way that I said, okay, that would be incorrect way to do this question for first. You would just take down each one of these percentages, and you would do them as a percentage, I would assume, if you do it this way. And then you would just divide by 4. Let's just see what this answer would be. This is the wrong way to do it, but this is a really, really common error for a lot of students to do it this way because they see that word average and then they're like, oh, I'll just add them up and divide by the number of them. 2.775%. Okay, so this is going to be totally the wrong answer. All right, now let's see what the proper answer is. After whatever amount of time this is, she is going to have $245,000 some change with it, and she started with 233. So let's use the definition of what ROR is. So remember, ROR is going to be the previous value, which in this case is going to be the current value, which is going to be the 245,534.89, minus her previous value, 233,365, divided by 233,365, and then of course we're just going to times it by 100 to get a percentage. So let's see what this is actually going to be. So in our calculator is 245,534.89. We're going to minus 233,365, and we're going to divide that by 233,365, and we're going to multiply that by 100. So we see here that her rate of return, her actual rate of return here over everything is going to be 2.51%. So it's that hidden word of average that really kind of messes with people's mind, because average is so built into you that you just take the sum of things and then you divide by, well, the number that they were. But in this case, that's not actually what you want to do. In this case, you actually want to take what she gets in terms of her return, and then you can get the average from that by adding them up and doing the rate of return as you normally would. Okay, there is a different way to do this problem, and I said I wanted to do that. Remember when we had our table here, and I'm not going to do it in its entirety, but I'm going to show you just a little bit of it. So we have our investment, we have the amount, we have our ROR, and then we have our return. And remember for this one, I said that you can multiply by 1.00, and I forget the number, 003 to get her total amount. Well, technically, you don't have to do it that way. You could take a certain amount, and instead of multiplying it by 1.003, you could just multiply it by the actual percentage, 003, and you would get what her interest would be on that, or how much she's going to be making on that. So that would just be like the interest that she would gather on it over time. And you could add all of the interests down to get the total interest for all of the ones. So just basically not having a 1 here and just having it that. And this total interest, well, that is the definition of current minus previous, right? So you could just kind of label that whole thing as that total interest would have equaled what we got from this here. So kind of two ways to do it. I kind of like doing it this way up here just because it follows the formula, if that kind of makes sense, rather than, doing something else and then having to know what this formula kind of deals with. I found that students kind of struggle a little bit with that. So in the end, you can do this any way you want to, just because if you understand the concepts, you're pretty much good to go. But if you're looking at it kind of like a foolproof way, I would just get the total amount. So like her amount plus the interest amount, add them all up, and then just use the rate of return definition to do that. So kind of slightly convoluted kind of example, couple different ways to do it. Hopefully that makes sense.